Here we have another system of equations. I told you they weren't all going to be easy, but did you listen to me? Probably not. Whatever. Do whatever you want. Well, in this one, they're both set up in standard form, which again is great for doing the elimination method. Now, unfortunately, nothing cancels right now when we try to add everything on the left. We get closest to getting stuff to cancel with the x's. If only this were a negative 3x, then we'd be in business. But we don't have a negative 3x. But there's this great thing that we talked about a long time ago called the multiplication property. What that will allow me to do is to multiply both the left side and the right side of this equation by the same constant and still get an equivalent expression. So if I multiply this times 3 on the left, I have to multiply times 3 on the right. Why would I want to multiply this times 3? Well, look. Let me cover up everything. Look at what you see. I have a 3x here. When I multiply this, I'm going to get a negative 3x. Those guys are going to be opposites. They're going to cancel. And then the only variable that I'll have remaining is my y. So let's rewrite this system of equations. The first equation does not change because I didn't do anything to that. So 3x plus 4y is equal to 14. The second equation, everybody got multiplied times positive 3. So that gives me a negative 3x plus 9y is equal to 17 times 3. That is going to equal 51. Now remember, the reason I multiplied this by 3 was so that I would get the x's to cancel. And that's exactly what happens. Here, these x terms cancel. Combine the y terms and you get 13y. On the right side, you end up with 65. Well, one equation, one variable, easy to solve. All we have to do is divide both sides by 13. Dividing both sides by 13 will yield that y is equal to positive 5. So, we have one of the coordinates. We just need to find the other one. You can plug the 5 into either one of these original equations. Alright, so let's just go for the top one. So the top one's going to be 3x plus 4 times, the y value is 5, so let's substitute that in. And this equals 14. So, 3x plus 20 is equal to 14. Subtract 20 from both sides. That means that 3x is equal to negative 6. Divide both sides by 3. And x is equal to negative 2. Notice that I'm not boxing these. When I put them together, we have the solutions negative 2, positive 5. You may be thinking, hey, we found 5 first. Why is it coming second? Well, remember that solutions are ordered pairs, and the proper order is x and then y. So, let's check our work. If we go into the first equation, we have 3x plus 4y is equal to 14. Replace the x by negative 2 and replace the 4 with positive 5. Does this give me 14? Negative 6 plus 20. Yes, that does equal 14. So it checks into one equation. Well, we need to check it into the other equation. The other equation, the original one, was negative x plus 3y is equal to 17. Well, I'm saying that x is negative 2, so negative times a negative 2 plus 3 times my y value, which is 5. Does this equal 17? A negative times a negative is equal to a positive 2 plus 15. And yes, this does check out. So before I turn anything in, I've checked my work, and I know that this is my solution.